Now let's see how integer overflows are handled in C versus how Rust strong design makes integer overflow behavior predictable all the time. So in this case, the right hand side is C code and left hand side is Rust code. So in case of C, there is a signed integer which is already assigned to its maximum. The maximum value is printed and there is an attempt to add 1 on top of the already stored maximum value, and the new value is being printed. So let us see what happens. So in this case, the maximum of I is 2,147,483,647, and in this case I plus 1 gives us a negative number. So the C standard says that signed integer overflow is an undefined behavior. The C standard does not define what must happen. Different compilers and different optimization levels produce different results and different output. So in this case it has wrapped around, and some cases it may produce an unexpected result, or else in some cases even the compiler simply assumes that no overflow happened at all. Right? So what is basically overflow? It is something like this. So integer overflow basically means the result of an arithmetic operation is larger than what it can hold. So in this case, the program started with integer maximum and 1 is added to it. So when 1 is added to it, see, it is 47 here, right? When 1 is added to it, it becomes 48. But because it's already occupying all the 32 bits, this one requires 33 bits, right? A 32-bit signed integer has only 32 bits to store a value. The largest positive value it can hold is 2,147,483,647. But when 1 is added to it, the mathematical result is this much, which requires 33 bits to represent. So because there are only 32 bits, the extra bit cannot be carried over, right? It cannot be stored. So this causes something called an integer overflow. In C, this is an undefined behavior and may produce different results, but Rust detects integer overflow differently in debug builds and differently in release builds, but both are predictable all the time. It's always the same. Okay, let us see the Rust program. So in case of Rust, there is a mutable variable binding. It's mutable because the value is being changed, right? So this binding I is of type sin32, similar to this, and it's already storing its maximum, just like C. There is an attempt to add 1 to it and the new value is being printed. Right, similar to C program. Let us see the output of this in both in debug build and release build. See, in case of debug build, it basically panics. It's a definite behavior, right? It says there is an attempt to add with overflow and it panics. See, the program stops and the bug is detected immediately at compile time. So in case of release build, right, let us see what happens. So in case of release build, it's a wraparound, and this also is a predictable behavior. Okay, so it detects the integer overflow and wraps around. So what is wrapping around? Let us see that part as well. So here in this case, it starts with the maximum. Adding 1 will go to its minimum. Okay, this is I32 maximum, this is I32 minimum. So this is called wrapping around for signed 32-bit integer. And this value is what we see there, predictable and printable all the time. So in case of, like in case of positive numbers wrapping around, if it is unsigned maximum, adding 1 to it, unsigned 32-bit maximum, adding 1 to it wraps to 0. Okay, that is its minimum. So basically Rust detects integer overflow during development itself instead of allowing it to go unnoticed. So in debug builds, the program stops with a clear error message. And how does it help? It helps developers identify the exact location of overflow. So this allows the bugs to be fixed early before the software is released. So there are some cases where overflow is intentional, like cryptography or low level programming. So we can use something like, there are some methods that Rust provides, like, wrapping underscore add, checked add, and all that. So for example, see, sometimes wrapping is intentional. So for example, if you have a clock, the maximum hour the clock can have is only 12, right? And if you want to, after 12, what do? We simply wrap around to 1, the minimum that it supports. So this is intentional. This part is intentional. Right. So similarly, in some examples, right. So, okay, let us see this. Adding 12 plus 1 is equal to 1. So it cannot become 13 here. Right. The clock has only space for 12 values. The wraparound will be, after 12, it will be 1, 2 and 3. Okay, so similarly, cryptographic algorithms, hashing functions, and checksums and other lower level algorithms are often designed to operate on fixed type integers, and they basically rely on wrapping around when they exceed the maximum representable values. So, but the intent here is very clear and specific. Right, so basically there are functions like, methods like wrapping underscore add. When the programmer's intent is clear and not accidental, then such kind of functions can be used. Okay, so basically Rust makes integer overflow an explicit programming decision rather than a hard time runtime surprise. Right, so in short points, what we can say, Rust detects integer overflow during development. It reports a clear error instead of silent continuing. It helps bugs earlier. It prevents incorrect program behavior caused by unpredictable behavior. Right. I think that's it for integer overflow.